Good day, everyone. So, we shall be diving into questions and answers on alternating current. Part 1. Yeah, let's dive into this. Example 1 says a voltage supply of 12-volt root mean square and frequency 90 Hz is connected to a 4 ohm resistor. Calculate the peak value of the current. Okay, so let's write out our parameters. So we are given a root mean square value voltage to be 12 volts. This is it here, and we are given a frequency of 90 Hz. The frequency of the voltage supply is 90 Hz. That's F, and then a resistor with resistance value of 4 ohms is given. So we are meant to calculate the peak value of the current being supplied by the voltage supply. Okay, so that's the peak value current I naught. So by formula, peak value current is equals to root mean square voltage multiplied by a square root of 2 over resistance. Okay, root mean square voltage is 12, so we substitute the value to be 12 and times root 2 over our resistance, which is 4. And then when we simplify this, we have our peak value current to be 4.2 ampere. Now, you will find out that we are given the parameters here, but we didn't use it in the solution. That is to say that it is not all the parameters that you use in some cases. All right? So let's take another example. Here it says, calculate the amount of heat generated in an external load of resistance 8 ohms if an AC of peak value 5 ampere is passed through it for 100 seconds. Okay, here we have to calculate the amount of heat. So we are looking for H. Either we are given a load of resistance 8 ohms, so that our resistance have a load of 8 ohms. We are given a peak value current to be 5 ampere, so our I naught is 5 ampere. We are given a time of 100 seconds. So now before we can calculate the heat, we need to determine our root mean square current. And our root mean square current formula is peak value current over root 2. The peak value current is 5, as written here, over root 2. So 5 over root 2 is 3.54 ampere. Now our heat formula is I square RT. That means the square of root mean square current times resistance times time. So our root mean square current is 3.54. So we square that 3.54 square multiplied by our resistance is 8 divided by 8. Then multiplied by 100. That's the time, 100 seconds. So all of these will give us 10,025.28 joules. Yeah, so let's take another example. Example 3 said a 220 volts 60 Hz AC supply is connected to an inductor of 3.5 Henry. What is the current passing through the inductor? Take pi to be 22 over 7. Yeah, so firstly, our voltage is 220 volts. Our frequency is 60, so F is 60. Our inductance of the inductor is 3.5 Henry, and we have to calculate the current. So to calculate the current here, current, which is I, equals V over 2 pi FL. V the voltage, so we have 220 over 2 times pi in decimal form is 3.142. That is 22 over 7 in decimal. Approximately 3.142. Then times our F, which the frequency is 60. Then times our L, which is the inductance, 3.5. So when you Simplify all of these, the current in the circuit will be 0.167 ampere. Okay, so let's go on to another example. It says, at what frequency would a 10 Henry inductor, at what frequency would a 10 Henry inductor have a reactance of 2000 ohms? So at what frequency will this inductor have a reactance of this value? So we're looking for frequency now. We're given the inductance to be 10 Henry, and we're given the inductive reactance to be 2000 ohms. So by formula, the frequency is inductive reactance over 2 pi L. Our inductive reactance, which is our SL, is 2000 over 2 times pi is 3.142 by constant, and the L is our inductance times 10. Simplify all of these, we have our frequency of the inductor to be 31.8 Hertz. Yeah, so now we go to the last question. Example 5. It says, at what frequency would a capacitor of 2.5 microfarad used in a radio circuit have a reactance of 250 ohms? Yeah, in this case, again, we have to look for frequency. So frequency is the unknown one here. We are given a capacitor of capacitance 2.5 microfarad. So capacitance here is 2.5 microfarad. And then capacitive reactance here is 250 ohms. So frequency for capacitor is equal to 1 over 2 pi CSC, where the C is the capacitance, XC is the capacitive reactance. So that will be equals to 1 over, substituting the values here, so we have 2 times our pi is 3.142, our capacitance is 2.5 microfarad. So this micro is a value of 10 to the power minus 6. So we have 2.5 times 10 to the power minus 6, then multiply by our capacitive reactance, which is 250, that is our XC, so times 250. So simplify all of the frequency of the capacitor is 254.6 Hertz. Yeah, so this is the last example for today. Thank you for listening. See you another day. Bye for now.